This is question number 7. Check your understanding from work, power, energy. This is actually a river boat question. It involves power concept also. So let us see what is the question and how should we approach this. Question is, there's a boat. It is installed with 2 engines. It goes from town P to Q. So this is referred to this figure. This is P and this is Q. They are connected by a river. So this is actually a river. And the boat takes T1 50 minutes on its way from P to Q. So boat is going in this direction. And when only one engine is on, then it takes 50 minutes. When both the engines are on, then it takes 25 minutes, half of the time. And it is also given the force of water resistance is proportional to the velocity of boat relative to water. Assume water flow velocity to be uniform and the boat always moves with respect to the water with maximum possible velocity, right? So this all information is given. We have to then find out what minimum time will the boat take on its way from Q to P, that means while returning, with one engine on. The same thing we have to find out with both the engines on, right? So I'm going to solve this. And once you have understood A part, you can solve B part by yourself. So I will solve only A part. So let us see first what all information is given. So here now, this is P and Q. Let us say only one engine, when one engine is switched on, it generates P power. And if suppose V is the maximum speed with one engine, then power of one engine is P and force will be what? If velocity is maximum, then there is the entire acceleration after accelerating, the velocity has become maximum, right? So maximum velocity corresponding to that net force will become 0. So force is equal to kV, right? This is the water resistance force. This force should be overcome. And this force into velocity. So power is equal to kV square, right? I hope you have understood. This is the key point. So this power is kV square. V is the velocity with respect to river. That is given in the question. Now, if both the engines are switched on, then power becomes 2P, right? And likewise, if maximum velocity becomes V1, then 2P will become kV1 square. From these two equations, first important conclusion which we have made is V1 is equal to root 2V. What is V? V is the velocity of boat with respect to river when one engine is on. V1 is velocity of the river with respect velocity of the boat, sorry, with respect to river when both the engines are on. Root 2 difference, right? Root 2 times. Now, next thing which we have to figure out is the direction of river flow velocity. If you just check the data here directly also, by some mental calculation, you can find out the direction of river flow velocity. So I'm going to prove this or figure this out mathematically. So I'm assuming that river flows from P to Q with the speed U. Right? So I have assumed that it is going from here to here. And then we will see how this data fits, given data fits. So if river is flowing this way, and if boat is also going this way, so V and U, and remember V is the velocity of boat with respect to river. So velocity with respect to earth will become V plus U, right? So then T1 is equal to D divided by V plus U, and T2 is equal to D divided by root 2V plus U, because what was T1? T1 was the time when only one engine is on. T2 was the time when both the engines are on. And it is given in the question that T2 is T1 by 2. Remember, 50 and 25 minutes. So if you do that, and if I put T2 and T1 here, you get something like this. U is equal to root 2 minus 2 times V. Fine, which is of course negative. So that tells you that river is not flowing from P to Q. It is flowing from Q to P, right? So these two are important conclusions for this question. After that, it's easy for us to solve this, just a little bit more calculation. Okay, so this one more conclusion we have made just now. We have concluded that river is not flowing from P to Q, it is flowing from rather Q to P. Now, A part I'm solving. Minimum time we need to find out from Q to P. So minimum time means maximum speed, of course. And with one engine on, so V is the velocity with one engine. So time minimum will be what? Now see what's happening. From this is P and this is Q, right? Boat is going this way. River is also going this way, V and U, right? So the time will be V plus U. Velocity of river with respect to earth will be velocity of boat with respect to river plus river with respect to earth. Both are in same direction, so V plus U. Now the only thing we have to do is to find out V and U in terms of T1 and T2 and D. So T1, what's T1? T1 is V minus U, right? Why? Because T1 was the time when the boat was going from P to Q, and we know that river is flowing from Q to P. So T1 is V minus U and T2 is D divided by root 2 V minus U. Why? Because this is both the, this T2 time is when both the engines are on, that time velocity is root 2 V. This time is when one engine is on, that time velocity is V, right? So I hope you understand. Now, from these two equations, you can find these two equations, right, in terms of V and U. And that calculation I have skipped, but you can do it just 2-3 lines. So after finding V and U in terms of D, if you substitute here in this equation, we are going to get this T1 is equal to T1 T2 root 2 minus 1 2 T1 minus root 2 plus 1 T2, right? So that's it. Now in a similar way, you can also solve the second part. Just that now second part you have to find out the time with both the engines on, right? So I hope you can do it now. So that's it. That was my analysis. If you have liked this video, if you have liked my analysis, the way I've explained, so if you have studied something, learned something from this, please hit a like button to this video. And if you subscribe to this channel, that will be a great motivation for me to continue. Thanks a lot. All the best.